Good morning, my grade sixes. Welcome. Welcome to our STEM Lockdown Digital School. It is so awesome to have you here again today. I can recognize quite a few names, so welcome again, welcome back. For those of you who are new, I am Sheena Cooney, I'm your teacher. Please note that if you want to send me any experiments, any work, you can just send it to my email address, sheenamelody@gmail.com. Then I can watch how you're doing. I can give you feedback. Thanks, Kiara, for reminding me. You may need to remind me a little bit today about your names because I might just get a bit mixed up. So thank you so much for being here. If you're a little bit late, don't worry, we've only just begun. I'm just glad you're here, and I'm glad you made it. So welcome. Right, today we are going to, once again, revise. Obviously, when we are talking about our solutions, we are revising making mixtures. We are still talking about solids and liquids, etc., and different materials. So it sounds a bit repetitive, but it's all links together. Okay. So welcome. Right. So what we learned yesterday was about rates of dissolving. Okay. So there were a few factors that affected the rates of dissolving. That was the temperature, the particle size, and your agitation or your stirring. Okay. Now solutes are your solids and solvents are your liquids. Now, in solutions, if you give different amounts at different times, that is what we call the rate of dissolving. All right. I have three little images there showing you also the different rates of dissolving with the temperature, the particle size, and the storing. Now, usually with temperature change, if the temperature increases, your solute or your solid will dissolve faster. Okay, so the hotter it is, the quicker it dissolves. Now, when it comes to your particle size, usually if the particle sizes are smaller, then your solute will also dissolve faster. But if your solute or your solid is a bit bigger and chunky and denser, then it'll take a bit longer. When it comes to stirring or what we call agitation, okay, if you agitate the solution or you stir it, then it also helps dissolve much faster than just leaving it. Because some solutes will just sink to the bottom if you do not stir it and take far longer to dissolve. Now, if you are, let's look at, for example, real life situations. Now, I don't know, some of you do make tea, don't you? You drink tea, you drink coffee, don't you? Okay. Now, that is the best actually example to give you about dissolving, the rate of dissolving. Okay, so imagine making a nice warm cup of tea and you add 3 teaspoons of sugar. Okay. Now, instead of your 3 teaspoons, some of us discussed this yesterday, we add 5 teaspoons. So you've got 3 teaspoons already in there. Now you're adding 5 more. So how many teaspoons do you have in there now of sugar in your tea? That's exactly right. You would have 8. Now, if you were to drink this tea, what would you notice about its taste? Very good. It would be very, very sweet, wouldn't it? Very sweet. Now, when the particles of the sugar spread through and they join the particles of the water, and because we're stirring them or the water is hot, we call this that the solid or the solute is dissolved into a solvent to make a solution. So your solute plus your solvent is your solution. Now, will the 8 teaspoons of sugar all dissolve in the water? Will all 8 teaspoons dissolve? No. So how many teaspoons of sugar do you think you can add to a cup of tea till it gets to a point where it will no longer dissolve? How much sugar do you need to add in there to get to a point where it no longer dissolves, do you think? You can just make an estimation or a guess. 50. Well, yeah, why won't it dissolve if you add so many? Yeah, that's a lot, 187, my word. That is a lot of sugar. Okay, so now that you've thought about that, can you tell me why? Why won't it dissolve when it gets to that point? See, Kiara says it will be saturated. Remember, when you add, the more sugar you add, the denser it becomes. And the denser it is, the harder it is, or the more difficult it is to dissolve. So it will be a saturated solution. Well done. Good job. Yes, that's very, very true. If you drink too much sugar, it will make you sick. Your stomach can't cope too much with that one. Right, so now this is what we know. Now remember that a lot of these things is revision and will be coming up when we do our Kahoot on Friday. So you are going to just, if you miss something or you don't get something, you can just take a note, okay? But otherwise you don't need to if you've got the notes. All right, so what we know is, we know that a mixture is 2 or more materials stirred together, okay? The property means, this is definitions now, so you might, if you don't have the definitions of some of these, you must please take them down, because these are, remember, these are the scientific definitions that I'm giving you. These are the ones that are in your book, okay, or in your textbook, or what you're studying. So just like take notes if you need to. All right. So property. Property is a characteristic of an object, something you observe. Okay. For example, the property of an object could be its color, something about its size, the shape, and the texture. Okay. Yes, JD? What's wrong? Don't worry, we do have a host, okay? So don't worry about that. Does it say I'm the host now? Okay, well, if anybody pops up on the screen for me to admit, I will do so, but at the moment, don't worry too much about that. Everything seems to be working fine, but I do have a host, so don't stress yourself. Rather just follow along with me, okay? So now, do you want to write this down? Don't worry, at least you're welcome. Welcome. So if you want to write this down, I'm going to give you a moment to do that. You know, I don't mind doing that. I would just like the rest of the class to also just be patient when someone's writing something down. Okay. So at the pictures, you can actually see we have a block showing color. All right. We have one showing texture, like the metal grating and the rough lines there. And then you have the size. For example, there's a big nail or bolt or pole lying there. Okay, so that is some examples for you. I think you do, most of you do have this one. All right. So let me know if I can go to the next slide. I'm not sure if there is someone writing. We're learning about solutions. Okay. At the moment, we're going through the definitions. All right. So we're going through the definitions and their meanings so that you have them. Some of them you probably know off by heart. Some of them you'll need to know how it's explained so that you can give that same answer. Okay, so I'm going to give you a minute. So if I'm quiet, I have not disappeared. I am here. Okie dokie. Don't disappear like the flash, yeah. No, I won't. That noise is just when someone joins the classroom. Okay, so don't worry about that. I can't actually switch that off, so it's like a doorbell, hey? All right, so can I go to the next slide? Are we good? All righty. Okay, I'll wait for you. Okay, some people are taking notes. That's why we're just waiting. All right. So thank you for your patience. Okay, we're just writing the definitions down of a mixture and the definitions down of a property. Welcome, Blessing. I'm glad you could make it. Welcome, Zanu. We've got some very nice classmates here today who are very supportive. All right. How are we doing? You can put off your own video as well. All right, so now, have we got that down? We don't want to stay too long. It's already 1:15. Judy, I don't know if I can actually put it off because I don't see it on my side. So, all righty. Now, the next definition that we're going to look at is called solution. Now, your solution is a special mixture formed when a material dissolves in water. Now, it's important to remember that your solution must be clear for it to be a solution. Okay. If it's not clear, it's not complete. The material is not completely dissolved and it is not a solution. So a solution is a special mixture formed when a material dissolves in water. Of course, you can take notes. And the solution must be clear. Dissolving, as you can see by the images, this we also did a little bit yesterday. We discussed this in quite a lot of detail yesterday. When one material disperses uniformly, in other words, it spreads around as one. It spreads around equally into the other material, into another material, preferably a liquid, and then the first material seems to disappear. Okay. If you can put your videos off, leave it off. There has been, is JD's video in front of you, really? Oh my, okay. Okay, let me see what we can do. All right, so there's an issue. Okay, let's see if we can resolve this. All right, I'm going to find out what we can do about this. Okay. Just see if you can put your videos off. All right. Okay, so you can't copy the notes properly because of the camera. All right, so until I can resolve that, I'm going to read it to you. Which note are you on? Okay, so solution, you're on solution. Okay, so I'm going to read it out to you until we can resolve this issue. Okay, so a solution is a special mixture formed when a material dissolves in water. So it's a special mixture formed when a material dissolves in water. What's your idea? Okay. Can you see the next part, the dissolving part? Do I need to read that one for you? Okay, you know what I'm going to do? I'm actually going to type it in here to everyone. Okay. I'm going to actually type it in the chat if you can't see it. Okay, so I'm going to type it here. So dissolving is when one material disperses uniformly, oh, I spelled that wrong now, into another material so that the first material seems to disappear. Does that help? Okay, so now, okay, so you exited the full screen and it's working for you. Okay, that's a good suggestion. Thank you very much. I am trying to sort it out. All right, so let's move on and I'll type if you can't see anything. If you can make your screen smaller, then hopefully it will help. Okay, so our next one is elements. All right. So elements cannot be reduced to smaller substances. So an element as it is cannot be made simpler. It is what it is. Now, everything on earth is made from elements. Okay. So you have, for example, gold. You have aluminium. You have copper. All right. You also have, if you look at the pie chart that I've put there, it has all the elements, the most common elements that we have on the earth, okay? And these cannot be reduced into anything simpler. Okay, that is what they are. For example, look at the first one. We have iron, magnesium, and oxygen. Okay, we have carbon and we have oxygen. So these are Earth's common elements, all right? And all you need to know is that they cannot be reduced to a simpler substance. Okay, do you want to take that down? Because I don't think we covered this one this week yet or last week. I know I didn't bring this up yet. And you just let me know when I need to go to the next slide. Okay. Because when I do our Kahoot quiz, I want to put some of these definitions in there so to see if you can understand what they mean. Oh, I'm so glad, JD. Well done. I'm glad you got it sorted. Ah, very good. It should be in your textbook. So then if you don't need to write it down, you can just look in there, but it sometimes helps that you can actually have your notes separately. Otherwise, you have to page through your science textbook. All right. Okay, so now, yes, you can, it should be in, it doesn't matter which textbook, if it's a CAPS, it should actually be in there. All right, so now let's go to our next slide. You don't need to draw the charts, you just can write the definition of the elements if you don't have it. Okay. Okay, I'll wait a bit, sweetie. Don't worry. I'll wait a bit for you. And if you go to, I've put a little website you can jot down. It's a singing video about mixtures and solutions. So if you want to go and watch it, you might actually enjoy it. All right. Okie dokie. Now, let's see what is on the next slide. Here we go. This is something that you probably learned this term that we're revising. I haven't revised it with you yet. We've discussed mixtures, but we haven't actually gone into their proper scientific names. Okay, so we know that mixtures, we can combine them physically, but they're in no specific proportions. They just mix. Okay, someone has asked me to go back. So what I'm going to do is I'm just going to type the definition in this little block here for you so that if I do go ahead, you can still actually have the definition. All right, so that you don't feel like you're missing out on anything. I can type quite fast. So let's have a look. I hope this does help you. There we go. Earth is made from bees. There we go. Okay. So now, if we look at the next slide, we know that, like, remember when we mixed the peanuts and the raisins, we could still see the mixture. Okay. Now, solids, liquids, and gases can also be combined to create their own mixture. All right. And when we want to define a mixture, as you know, they're two or more substances which you combine or you mix together, but there's no chemical reaction. All right, you can just mix them together. Absolutely, I'm going to be a while. There are two types of mixtures. There's heterogeneous and homogeneous. Okay. Now, homogeneous mixtures, you can't see the components separately. So, for example, when you mix your sugar in your warm water and you stir, and you agitate it and it dissolves, that's a homogeneous mixture because you can't see them separately. Or when you mix salt and sugar, you mix them together. Can't really see them clearly separately. All right. A heterogeneous mixture is where you can see them. So if you mix stones with soil, you can see the stones and you can see the soil. Okay. We are done with term 2's work. I'm just doing revision before term 3. Okay. So now you have those two kind of mixtures. So those are two definitions that you should have or you do need to take down. Okay. One, you can see the components separately, and the other one, you cannot see them separately. All right. So I'm actually going to do it here. So we've got a heterogeneous mixture. Okay, so this one, you can see each component separately. For example, I will put here a mixture of stones and soil. Okay, so there's your one definition. All right. Okay, can you see that? And then we have homogeneous mixture where you can't see each of the components separately. Does this help, Kiara? There you go. So I've actually put it in the chat so that you can see. All right. Okay. Well, because we've actually got these notes on PowerPoint on our website, so you can actually see it there. All right. So it would be the same thing as Flipgrid. Okay. So you're welcome if you know our African Teen Geek website, you just go there, you go into our grade, you go into our subject, and you will find the PowerPoints there. Okie dokie. Okay, so don't you have the notes of the other stuff from yesterday? Very good. You have given me an example of a homogeneous mixture, powdered sugar and flour. Very good. That's a good example. Okay. So which one are you on, Kiara? You on Kiara, do you know how to get to our website so that you can go onto the PowerPoint, or you're not able to do that? Shame, because I feel bad for you trying to write everything down. So this is what you do. Oh, does it go weird? Okay, so if you go to see, and then you actually go to lockdown, eSchool, and then you go to grade 6 NST. No, it's good that you're writing. I'm very proud of her. Because when you write, it's like a computer. You're actually putting it inside your head today. So it's very, very, very good to write it down. That's how I also remember things, by writing them down. Okie dokie. So how are we doing there, sweetheart? Who can give me an example of a heterogeneous mixture? No, it's good, Kiara. It's good. You keep going. So you can give me an example of a heterogeneous mixture. There we go. Peanuts and raisins, rice and beans. Very good. And what about a homogeneous mixture? So this is where you can't see the components separately. There we go. But with salt and pepper, can you not see the salt and pepper grains when they're mixed? There we go. Salt and sugar is hard to see. Okay, you know what you can also do, Kiara? If you give me your, if you send me an email to my email address, and I can send you PPT or notes that are on our site, or anything you haven't been able to write down. Okay, maybe I can help you that way. Might be easier for you. Okay, so Adele, just take down my email address, and then if there's anything you've missed, just let me know, okay? And then I'll try and help you out. I honestly don't mind. Okay, so these are one of the types of questions that are going to come up. So what is a mixture? A mixture, you already have this down, is made of two or more types of atoms, and they are not chemically combined together. All right, so they have many forms. I've actually given you some examples. So there's two, if you mix two solids, that's a mixture. If you mix two liquids, that's a mixture. If you mix two gases, that's a mixture. If you combine a solid, liquid, and gas, it's a mixture. Okay. There we go. Well done, Savannah. That is some awesome examples. Sand and sugar, salt and gravel, toy box filled with toys, pizza, very good, cereal and milk, rocks in the sand at the beach, banana splits, ice cubes in a drink. So many things around us are mixtures. Well done. Good job. Well done. I'm very proud of you. Okay, so our next example is a mixture. It's just a mixture of solids. Okay, so you can see that the pasta is different colors, but you can see them when they mix together. The coins, they mix together, but you can still see the different colors and different shapes and different sizes. There are some pulls there, and you can see, although they mixed, you can still identify the different colors. We also have a jar there of like peppercorns. All right, so although the different types of peppercorns are mixed, you can still see them. Okay, so I'm just showing you a few visual examples. This is a mixture of liquids. So there you have your orange juice, okay? You have your coffee, which is a mixture of water and powder. You have your juice, which is a mixture of water and concentrate. Okay, so you have also your little jars of examples there. Alrighty, ink and juice. Well, it'll be more like maybe food coloring, wouldn't it? But yes, ink, if you mix ink in water, yeah, it will mix together. We also have our mixture of gases. All right. So we have our helium balloons over there. Okay. And we definitely can mix our gases. Who wants to give me an example of gases mixed? Just having some water. Okay. Okay, but to make those gases, yes. Nitrogen and hydrogen. They are definitely can be mixed. What other gases can be mixed? Okay, that is so cool. Well done, guys. All right, let's go to our next one. I am fine. My voice just dries up when I talk a lot, so it does happen. Okay, so your types of mixtures, which we did today, there are two major types of mixtures. You've got your heterogeneous. Maybe you do want to get this one down. If you don't get it down, just please email me. It is not a problem. Heterogeneous simply means different, so you can see the different parts in the mixtures. Homogeneous means the same, so you cannot see the different parts. Okay, well done. Carbon dioxide and oxygen, good. Very good example there. Okay. Right, now look at the mixtures that I have here. Okay, how do we classify them? Heterogeneous and homogeneous. So you'll see the cereal is heterogeneous. Okay, so the cereal, you can see that there are different particles and different mixtures in there. With the grape juice, you can't see because you can't see the different mix. You can't see the water and the grapes. It's all blended and dissolved together, the concentrate. So that's homogeneous. Okay. Then you have your mix of little sweeties there that are mixed up. You can see the difference. So they are heterogeneous. Well, I'm going to enjoy those 5 minutes because I want to spend it with you guys. Alrighty. So this, I'm going back for Kiara. Okay, so that she can just get that 2 little definitions there of different and the same quickly. Okay. I can't believe you're counting down. It's like you want to leave me. I'm not ready yet. I hope you guys did some experiments for me, some of these experiments, and you can share it with me on Flipgrid. Did any of you do that? Because that would be really cool, or take a video and send it to me. I'd really like to see your experiments. I will go at the end of this day after my lessons, I will go onto Flipgrid and I'll go have a look to see if you tested out our experiments. Okay. And I am going to make a big fuss over someone who has done it for me. Yeah. But if you can't do it, don't feel bad. I do understand. All right. I do understand. If you can't do it, we've got a lot of things to think about, like data, etc. Okay, so the code is, who remembers the code? It'll need to be on, it is quite a long one, isn't it? No, not that code. The code, the Flipgrid code. Okay, so I'll scroll down now and I'll just go and get it for you once we can. We've got some time here. Okay, so what I'm going to do quickly, all right, I'm going to actually scroll down to, I'm going to go very, very fast because I can always add these slides in tomorrow, so don't panic. I just want to show you, oh dear, what did I do? I want to show you the Flipgrid page. Okay, so, all right, it's not on this. There we go, Super 6 Science Geeks, well done. Well done. Thank you. So that is the Flipgrid code. And I'll add it also to the front of tomorrow's PowerPoint. Okay. Well, when you add in the code, it'll take you to the page. Okay. So it'll take you to the Flipgrid page. It'll say grade 7. You click on it. It'll show a green button with a cross. You click on that and you just share. Okay. Thank you so much for joining me, guys. Tomorrow, I'm going to put the Flipgrid details on the beginning of the slide. Okay, I think that would be much better. And remember to email me if you need some notes or if you need to ask any questions. Okay, I love you guys. Have a great, great afternoon. See you soon. Bye.